Good evening to all. Myself Puneet. Today we are going to discuss about introduction to looping statements in C using while loop. Introduction to looping statements. The while loop. Looping statements are fundamental control flow structures in programming, allowing a block of code to be executed repeatedly based on a specified condition. In C programming, the while loop is one of the most versatile tools for achieving this. It provides a way to execute a set of instructions as long as a given condition remains true. This document will guide you through the intricacies of the while loop, from its basic syntax to advanced applications, common pitfalls, and comparisons with other looping structures. What are looping statements and why are they important? Looping statements, also known as iteration statements, are essential for automating repetitive tasks. Instead of writing the same code multiple times, looping loops allow you to define a block of code once and have it execute multiple times. This not only makes your code more concise and readable but also significantly reduces the potential for errors. Consider scenarios where you need to process a list of items, perform calculations until a certain threshold is met, or continually read user input. Without looping statements, such tasks would be cumbersome and inefficient to program. Loops empower developers to build dynamic and responsive applications that can handle varying amounts of data and execution requirements. Efficiency, avoid repetitive code and save development time. Readability, cleaner, more organized code that's easier to understand. Flexibility, adapt to varying data sizes and dynamic conditions. Understanding the syntax of the while loop. The syntax of a while loop in C is straightforward yet powerful. It consists of the while keyword followed by a condition enclosed in parentheses and then a block of code, the loop body enclosed in curly braces. While within the brackets condition open for brace hash statements to be executed repeatedly and flower bracket will be closed. The condition is an expression that evaluates to either true or non-zero or false zero. As long as this condition remains true, the statement within the loop's body will continue to execute. Once that condition becomes false, the loop terminates and the program flow continues with the statement immediately following the loop. It's crucial to ensure that the condition eventually becomes false to avoid an infinite loop, which can cause your program to hang. How the while loop executes, a step-by-step explanation. First of all, exit loop, continue after loop, execute body, run loop statements, check condition, evaluate while expression, start, initialize the loop entry. The execution of a while loop follows a precise sequence. The program first evaluates the condition specified in the while statement. If the condition evaluates to true, any non-zero value, the statements inside the loop's body are executed. After the loop body has finished executing, the program returns to step 1, re-evaluating the condition. This process repeats until the condition evaluates to false, 0. Once the condition is false, the loop terminates and the program processes that to next statement after the while loop. Understanding this flow is key to writing effective and error-free while loops. Also, always ensure there is a mechanism within the loop body that will eventually change the condition to false. Practical examples using while loops for counting and iteration. While loops are incredibly versatile. Let's look at some common practical application. Example 1. Simple counter. Hash include less than standard input output headed file. Int main opens flower bracket opens int I equals to 1 while of condition while of I less than or equals to 5 printf count percentage d and comma I plus plus increment is I is eventually making condition false. Flower brackets open return 0. In this example, the loop prints count followed by the value of 5 from 1 to 5. The I plus plus statement is crucial as it modifies the condition ensuring the loop terminates. Example 2. Iterating with a condition. Hash include less than standard input output headed file int main int sum equals to 0 int number equals to 1 while of sum less than 10 sum plus equals to number printf current sum percentage d hash n comma sum num plus return 0. Implementing user input with while loops. While loops are perfectly suited for handling user input, especially when the number of inputs is unknown, or depends on user interaction. This follows programs to respond dynamically. hash include less than standard input output dot headed files int main public open int number printf enter numbers 0 to quit hashed m scan of percentage d comma ampersand number read first input while of number equals not equals to 0 printf you entered equal percentage d hash n comma number printf enter text next number 0 to quit hash n scan of percentage d comma ampersand number read subsequent inputs printf loop terminated dot goodbye hash n return 0. In this scenario, the program continuously prompts the user for input. The loop continues as long as the entered number is not 0. Once the user enters 0, the condition number not equals to 0 becomes false and the loop exists. This pattern is common in iterative programs, menu-driven applications, and data entry systems where the termination point is determined by user action. Nested while loops, when and how to use them. Just like other control structures, while loops can be nested within one another. A nested while loop means one while loop is placed inside the body of another while loop. This is particularly useful for tasks that involve two-dimensional structure like matrices or when iterating through combinations of data. For example, hash include less than standard input output dot headed files in the main for brackets open int I equals to 1 while I less than or equals to 3 outer loop integer I j equals to 1 while of j less than or equals to 2 inner loop print I percentage j percentage hash n comma I comma j and j in plus plus it's called increment flower brackets close I plus plus increment flower brackets close return 0. In this example, the outer loop runs 3 times. For each iteration of the outer loop, the inner loop runs 2 times. This results in a total of 3 into 2 equals to 6 iterations of the inner loop body. Nested loops require careful management of their respective conditions to ensure correct termination. Typical uses for nested while loops include printing patterns, example stars, numbers in row columns, processing elements in a 2D array, or mat generating combinations or permutations. Common pitfalls and best practices for while loops. Infinite loops. Ensure the loop conditionally eventually becomes false. Forgetting to update the loop control variable is a common cause. Off by one errors. Carefully check boundary conditions. Example less than or equals to vs dot less than to make sure the loop runs the exact number of times intended. Uninitialized variables. Always initialize variables used in the loop condition or body before the loop starts. Performance. Avoid complex calculations with the loop condition if they don't need to be re-evaluated every time. To write robust while loops, consider these best practices. Clarity. Make your loop conditions easy to understand. Update mechanism. Clearly define how the loop's control variable or condition will change within the loop body. Test boundaries. Test your loops with minimum, maximum, and typical conditions input values to catch edge cases. Comparing while loops with for and do while loops. While the while loop is powerful, C offers the other looping constructs. Each suited for different scenarios. Understanding the differences helps in choosing the most appropriate loop. While loop. Condition controlled checks condition before execution loop body may not execute at all. When the number of iterations is unknown and depends on a condition that changes during execution, user input file end. For loop, entry controlled combines initialization, condition, and update in one line, best for definite iterations. When the number of iterations is beforehand, iterating a fixed number of times array traversal, do while loop. Exit controlled executes loop body at least once, then checks condition. When you need to execute the loop body at least once, regardless of the initial condition, menu display for user input. Each loop type has its strengths. The while loop's flexibility in handling indefinite iterations makes it a cornerstone of C programming. Conclusion and further learning resources. The while loop is an indispensable tool in a C program's arsenal, offering a robust way to implement iterative logic. By mastering its syntax, execution, and practical applications, you can write more efficient, readable, and dynamic programs. Remember to always manage your loop conditions carefully to prevent infinite loops and ensure correct program termination. To deepen your understanding and explore more advanced concepts related to looping statements in C, consider these resources. Tutorials point C, Loops Geeks for Geeks, Loops in C Programming, C Loops. Thank you.